Herman Miller is a global furniture company that's been operating for over a century. Over the last several decades, they've been at the forefront of innovation and design in the office furniture space, with leading furniture designers shaping the vision of the company. With products like their Aeron, Cosm, and M-Body chairs, they've developed a reputation for superior design and sustainability in the workplace across the millions of units they've sold. At Herman Miller, the designers have been at the core of their success. They receive thousands of customer requests for fabrics to be used in their furniture. Currently, designers have to waste precious internal time and money manually searching thousands of fabrics to find alternatives to be used for these requests. We designed an artificial intelligence system, FIBRE, which stands for Fabric Identification-Based Recommendation Engine. Our goal with FIBRE is to aid designers to save them precious time that they can use to innovate and bring the next generation of groundbreaking furniture to market. This is Ted. He's a designer at Herman Miller. Let's look at what his day looks like without the use of FIBRE. For a user fabric request, he has to manually search Herman Miller's thousands of fabrics to find a match. This process is very inefficient and wastes a lot of Ted's time. Let's see how FIBRE can aid Ted in quickly finding fabrics using machine learning and deep learning models. Ritwick is a Herman Miller customer who really likes the design of this wall. He wants a piece of furniture with similar fabric. He can simply take a picture of the wall and send it to Ted. Without leaving his computer, when Ted gets the email, he can drag the picture into FIBRE's system. FIBRE uses machine learning to instantly tell him the color and pattern of the design. When he clicks on recommendation, he is shown 4 images in Herman Miller's database that have a similar color and pattern. From there, Ted can choose the one he thinks is the best fit and send to Ritwick to see if he likes. FIBRE did all the work of determining the design type and used deep learning to find close fabric matches in a couple of seconds, making Ted's life a lot easier. Machine learning and deep learning are 2 very fundamental components in our project and are used in our classification system. Our algorithm breaks the input image into small chunks and extracts the RGB value of each window. These RGB values are fed into an AdaBoost classifier using a decision tree as the base model. We trained our model on over 10,000 labeled fabrics from Herman Miller. The classifier outputs a color data point for each window, As our algorithm iterates over the full image, it generates a rich multicolor distribution that we can then use for our color classification. For our pattern classifier, we retrained the bottleneck layer of a convolutional neural network, ImageNet Inception v3. We trained our neural network on thousands of Herman Miller fabrics, and it learned proper separation of patterns in the feature space, as shown in the simplified network here. Both our color and pattern classifiers achieved over 95% accuracy with our test data.
Through a hybrid approach that utilizes both autoencoders and a match score algorithm, our system can classify and correlate Herman Miller fabrics to any fabric a user may upload. When a user uploads a picture of a textile to retrieve similar fabrics, we break the uploaded picture down into 12 color percentiles in one pattern categorization. Using that data, we then query the color percentiles of our fabric dataset using a k-nearest neighbors method to find the closest matching fabrics.
An autoencoder is a type of neural network that learns to compress the input data into a smaller feature set that we can use to give more accurate recommendations.
Along with our web app, we developed a cross-platform mobile app with the same functionality as a web app to make the end-to-end process easier. A user simply takes an image of a fabric and gets back the classification results instantly. They can tap recommendations to see similar fabrics in Herman Miller's database. We added a statistics page to show the color and pattern distribution of previous searches. This app can be used by both designers and customers to quickly get feedback on fabric requests.
So the FIBRE API is a RESTful API that we developed in order to deliver the full functionality of our FIBRE system. We hope that Herman Miller can use FIBRE in effective ways in order to increase productivity and aid designers to create more innovative furniture.